Hi, this is Jeline from the Honors Tutorial. Our topic for today is about division of radicals under Mathematics 9. We have here our first example, so that is square root of 24 over square root of 6. And this is how we are going to solve for it. Let's write the solution here below. So we can simply divide this because they have the same index. So square root of 24 divided by square root of 6, so that is equal to square root of 4. Because 24 divided by 6 is 4, and then don't forget to include the radical symbol. And then let's simplify. Square root of 4, that is equal to 2. So the answer for example 1 is 2. Let us have another. We have here example number 2. So we have here square root of 100 over square root of 225. So this is our solution. Let's write solution here. As you noticed here, 100 and 225 is a perfect square number. So therefore, we can just get directly the square root of 100 and 225. So it is easier. Square root of 100 is 10 over square root of 225 is 15. But always remember that this is not the final answer since we are talking about fractions, because the final answer of a fraction is always in its lowest term. So kindly think of a number that can divide 10 and 15 at the same time without remainder. So that is 5. We can use it. 10 divided by 5, that's 2, and 15 divided by 5 is 3. So the answer is 2 over 3 for number 2. Let us have another example. So we have here square root of 16b plus square root of 4b. So we can simplify this, don't worry, though it has a variable. So this will be our solution. So for this part, since they have the same index, we can just simply subtract b and b because we are dividing. So they have the exponent of 1. 1 minus 1 is 0, so cancel this. So now we have here square root of 16 over square root of 4. You can just simply get the square root of 16. Square root of 16, that is equal to 4, over square root of 4, that's 2. So 4 divided by 2 is 2. So this is the final answer for example 3. Example number 4. Let's write the solution for this kind of example below. Solution. For the first part and for the part here below, let's simplify first. Let's think of a number that can divide 40 and 125 at the same time without remainder so that we can simplify them. So let's use 5 to divide. So if we divide 40 divided by 5, then it will become 8. And then let's just copy first the variable and the exponent over 125 divided by 5. That is equal to 25. So we have here square root of 25a. And then let's focus now on our variable. Since we have here the same index, we can simply subtract the variables, the exponent of the variables that we have here. So that is 8 minus 1. So that is 7. So now we have here square root of 8a raised to 7 over square root of 25. We place the difference between 8 minus 1 on top, which is on our numerator. It is because 8 is the larger number compared to 1. So therefore, 8 should have the difference in 8 minus 1 a while ago. So now we can simplify this. For 8, you can think of factors of 8. One is a perfect square number and the other one is not. So we can have here 4 times 2 times a raised to 7. Don't forget to extend your radical symbol just to indicate that a raised to 7 is still included. Square root of 25, that is 5. So like let's write it here below. And then for the numerator, let's simplify square root of 4 and that is 2. So we have here 2 and then copy square root of 2 times a raised to 7 over 5. And then we are not yet done with the numerator because we can still simplify a raised to 7 because we can divide it by 2 here, our index. Though it is not written there, but it is there. It is just invisible because it is 2. 7 divided by 2 is 3. So that is 3 remainder 1. So we will be having 2a raised to 3 outside. That is the quotient earlier. And then the remainder should be placed inside still the radical symbol. And then for 2, we will just copy it. And then same with the denominator. So the final answer here is 2a cubed square root of 2a over 5. So that's the final answer. Next, let us have another example. We have here example 5, which is the cube root of 2 over cube root of 4. And this is how we are going to solve for it. Let us write the word solution below. So solution. Let's copy the given. So we have here cube root of 2 over cube root of 4. So the first thing that we have to do is to simplify this. How? Because they have the same index, we can divide 2 and 4. Just think of a number that can divide 2 and 4 at the same time without remainder, and that is 2. So now 2 divided by 2 is 1. So it will become cube root of 1 over 4 divided by 2 is 2. So cube root of 2. Let's continue solving. So cube root of 1 is 1 over cube root of 2. And then we need to rationalize our denominator. So let's copy again 1 over cube root of 2. And then we have to multiply it by cube root of 2 squared over cube root of 2 squared. in order for us to simplify the denominator, because we don't want any radical symbol in our denominator. So that's why we are rationalizing it. So 1 times cube root of 2 squared is equal to cube root of 2 squared over cube root of 2 times cube root of 2 squared is equal to cube root of 2 cube. We just add the exponents because they have the same base. So now this is what we are going to do. Since in our denominator, we have here the index 3 and the exponent 3, we can just cancel this out. So for our denominator, we have here 2. And then for our numerator, kindly simplify 2 squared. So it will become cube root of 4. And this is the final answer already. Cube root of 4 over 2. So that's it for the first part of our topic, part 1 of division of radicals. I hope that you have learned something today. If you have further inquiries about the topic or about us, kindly message the Honors Tutorials page. Thank you and God bless.